All right, you guys ready? Okay, here goes nothing. Guys, last week we did all kinds of rigid transformations, isometries. Okay, we preserved all of the angles when we transformed our figures. We preserved all of the side lengths. Okay, is this sounding familiar? And we did it without coordinates. Okay, we just blank sheet of paper, we had our figures, we rotated them around points, we reflected them in lines, we translated them along vectors, we did all that fun stuff, and we didn't have any coordinates. So now we're going to be doing those same things, but we are going to have a coordinate grid. So we are going to start off with reflecting. Okay. So what I need to remind you is that our line of reflection for our figure is the perpendicular bisector for the segments that are connecting our pre-image points to the image points. So this is perpendicular to the segment connecting A and A prime, and it is bisecting it into two congruent pieces. Okay, same thing with the B to B prime. Okay, it's perpendicular and is chopped into two congruent segments. Okay, B prime is equidistant from the line of reflection compared to B. It's the same distance. Okay, and it's got to be perpendicular distance, because if I do this distance over here, well, now it's a lot closer to the line of reflection. It's not really that far away. Does that make sense? I can't do it some weird angle. It has to be at 90 degrees. Any questions? Okay. Okay, so we know that a reflection is a transformation across a line called the line of reflection, so that the line of reflection is the perpendicular bisector of each segment, joining each point and its image. The pre-image and the image must be equidistant from the line of reflection. Okay, easy peasy. We kind of already knew all that. So in the coordinate plane, we're just going to look at what happens with one point, okay? These coordinate rules are kind of handy when you're reflecting in the x-axis or in the y-axis or in the line y equals x or in the line y equals negative x. They become less useful when you're reflecting in other lines. So I don't know how beneficial it's going to be to memorize them. I can't remember them, and I teach how to do this. So I'm going to teach you how to figure them out so that you don't have to memorize them, so that you understand where they come from, so that you can reflect in any line anyone ever throws at you. Does that make sense? Okay. So what I like to do is I pick an ordered pair. Now the rules to the ordered pair are pretty simple. You want to pick usually something from the first quadrant where everything is positive, because that's the easiest to work with. You do not want your x and your y value in your ordered pair to match, because then you can't tell if they switch spots. Like, how do you know if a 2 and a 2 switch spots when they're the same? Does everybody understand what I'm saying? Okay. I like to make them different enough so that it's obvious to me which one is which. Like this to me looks like 1, 3. So my point P is going to be 1, 3. Now, if I reflect the point 1, 3 into the x-axis, over the x-axis, and it's going to be perpendicular and the same distance below the x-axis. What would the coordinates of P prime be? 1, negative 3. Oh my gosh, I did it wrong. 1, negative 3. So, did we change the x? No. So, the coordinate rule is keep the x. What did we do to the y? It went from positive to what? Yeah. So we just make the y negative. Done. Didn't have to memorize it. All I needed was a little point to do a test on. Okay? You don't have to memorize these. For some of you with limited working memory like me, it's exercise in futility to try. Okay, so here's my new P. I'm going to call this 2,3. That's just kind of what it looks like to me. Okay, if I reflect 2,3 in the y-axis, it's going to be perpendicular and the exact same distance away on the other side of the y-axis. So do you see that this time the height didn't change? Is it the same height? So we're going to keep the 3. What changed? The x became negative. Okay, it's the exact same distance away, but on the opposite side. So now it's negative 2, 3. So if I'm looking at, okay, well my 3 didn't change from my y. This time I'm keeping the y, but I have to change the sign for the x. And that's the coordinate rule. So, these cute little coordinate rules are telling you the input, input, and then this is obviously the output. Okay? That's the input and output for those transformations. They're like little rules that tell you what to do. Okay, so far so good? All right. I am going to show you where this equation comes from. And then this is an algebra thing. So if you don't understand it, or like you need more practice, you're going to be in charge of having to go review it, because we need, like you guys are in here because you did well in algebra, right? Like there are certain things that we have to take for granted that you remember how to do. All right, so if you're thinking about y equals mx plus b, and I have a line whose y-intercept is the point 0, 0 because it goes through the origin, and whose cute little slope goes up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. I got a little off, but you see what's happening, right? If my slope is 1, what would the equation be for that line? So what's the m? 1. So if it's 1x, do I have to write the 1? Okay. And what's the b value? Okay. Okay, it's 0. If it's 0, do I have to write plus 0? That's our line, y equals x. Okay? So if the line is y equals x, what is the y-intercept? 0. Yeah, it goes through the origin, right through there. What is the slope? 1. Goes up 1, right 1, up 1, right 1, up 1, right 1. Everybody got it? Okay. So our cute little point P is up here floating around. What does that look like to you guys? 1,3 or 1,4? Okay. So this is going to be our point 1, 4. Okay, so remember I'm going to go the exact same distance on the opposite side of my line of symmetry. Okay, and it has to be perpendicular. So where does that put my P prime? How much to the right?
4.
How much up? So what happened to my X and Y coordinates? Yeah, they just flip-flopped. So whatever I put in for my X, that's going to end up being my Y coordinate. Whatever I put in for my Y, that's going to be my X. Okay? Do you guys see how you don't have to memorize these? All you need to do is pick a cute little point where you can tell the difference between the X and the Y, and you can figure any of these out. Easy, no problem. All right, what about this one? So, what's the slope of this line? -1, but you can see it has the same y-intercept, right? Because it goes right through the origin. So on this one, it's like this, but now our m equals -1. All right, so here's my p. That looks like 3, 1. Okay? Same distance away on the opposite side of my line of reflection. Perpendicular. It's kind of looking like left 1 down 3, right? So left 1 down 3. Oh my gosh. What happened? Yeah, not only did they change places, they also changed quadrants and signs. They went from both being positive to both negative, right? So we're going to do the opposite of y, the opposite of x. And now when I ask you the coordinate rules, I'm going to need you guys to like flip back to these quickly, because when I ask, I really don't know because I can't memorize them. Like my memory is garbage. I think I drank too much Diet Coke in my 20s, and that had, what is it, aspartame in it, whatever it is, and it's really bad for memory. So, yep. Okay, we are going to reflect this triangle across the y-axis. So let's draw in our line of reflection. Oh, I wanted it to be pink. Okay, there's my line of reflection. So if you understand what you're doing, you can really do this in any line ever, and you're not restricted to the 4 lines that are on the front of this paper. Okay, let's start with x. If I go perpendicular to my line of reflection, how far to the right is x? Okay, so how far to the left will x prime be? Did I need a rule for that? Nope. It may almost be easier without the rule for some of you. All right, look at y. How far to the left is point y? I see 4 also, so we're going to go 4 to the right. That's y prime. All right, what about z? 3 to the right, so we're going to go 3 to the left. Okay. I'm going to use my straight edge and connect my points. Okay, it should be pretty obvious if you've done it correctly or not. It should look like a reflection. Notice how it kind of looks all butterfly-ish? Okay, if you want the extra added satisfaction of knowing that you're correct, you can be a little extra and make sure that your line of reflection is the perpendicular bisector for each one of the segments that connects your image to its pre-image. Bam. That's not required, I'm just kind of making a point that that's what's happening. Sound effects, optional. So, if we were to apply the rule, let's say that they didn't give us a graph and we just had these points. Okay? If we're reflecting in the y-axis, we are going to change the sign on the x's and keep the same height, keep the same y. So I know that my x prime would be the opposite of 2, but it's going to stay at a height of -1. My y prime, instead of being left 4, would then be right 4, but it's still going to be 3 below. My z prime, instead of being 3 to the right, would be 3 to the left, but it's still at a height of 2. So I can do it with a graph, and I don't need the rule, or I can use the rule, and I really don't need the graph. Easy peasy lemon squeezy. Okay, so I did one for the y-axis. Do you guys see, I don't have one on here for the x-axis. You see that for the x-axis it would just be flipping this way instead of this way. Okay, so we're not going to do an example with the x-axis. I need you to extrapolate and realize that we would just be changing the y's, the signs on the y's, instead of the x's. Is that okay with everybody? All right. Now, instead of doing, like I said, the x-axis, we're going to do the line x equals 1. Do you guys remember your Hoy and Bucks? Whew. All right. Get ready. Here we come. Hoy and Bucks is a little memory device to help you remember your horizontal and vertical lines, because it gets a little confusing when you're trying to remember a bunch of other stuff. So if you have a y equals some number equation with no x, that means it's going to be horizontal. I mean, you think about it, if it's y equals some number with no x, the slope is 0, right? Because there's 0x. And all it is the y-intercept the entire time. It's constant. It's always the y-intercept, the b value. Okay? So 0 is the slope, the m. All right. Similarly, if you have an x equals equation with no y, it just has x equals a constant, some number, it's going to be a vertical line. Okay? Vertical lines have undefined slope. That's because when you have a vertical line, your rise over your run is going to be some number divided by 0, because your run is 0. If you're going straight up and down, you're not running at all. You're not going sideways. Does that make sense? Okay? Any number, no matter how small, any number compared to 0 is infinitely large. Anything you got, infinitely larger than 0. So it's undefined when we divide by 0. Everybody happy with that? Okay. All right, so if I have the line x equals 1, horizontal or vertical? It's vertical. It's x equals 1, not y equals 1. So I look for all of the points whose x value, I meant to do dashed, whose x value is 1, and they're all right here. Oh my gosh. Okay, I've got the point 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5. What do they all have in common? The x is 1. That's why it's called x equals 1. The y can vary, the x has to be 1. Okay, so now we're going to reflect our points. So we're not going to use the rule at all for this because we're not reflecting in one of the cute little lines on the front. You see my S is 2 to the right of my line of reflection. It's going to go 2 to the left. S prime. Okay, my V is 3 to the left. It's going to go 3 right. Okay, my T is 2 right, it's going to go 2 left. U is 3 left, it's going to go 3 to the right. Okay, go ahead and connect your vertices. Oops. Easy peasy lemon squeezy. Okay, so if we were reflecting in the line y equals 1, y equals 1 would be here. So we would go this way. Everybody able to visualize what that would look like? So actually, the points U and T, because they're on the line of reflection, they would just stay where they are. Okay, so this is what it would be if it was y equals 1. And this, of course, was x equals 1, which was our directions. Do we want to do the y equals 1 really quick, just so you have an example like that, or do we get it? You want to do it? Okay. So, just for bonus round, U would be U prime, because it's on the line of reflection. T would also be T prime, because it's on the line of reflection. How far above the line of reflection is point B? 3. So it's going to go 3 below. There would be our V prime, and same with our S prime. Connect your points. So you can see the difference between reflecting in a vertical line and reflecting in a horizontal line. Cool. All right, this time we have a segment R and S. R is located at -2, 2. And S is at 5, 0. Okay, we are reflecting in the line y equals -x. So where should the y, yep. What did I do? Oh yeah, I definitely messed that up. Good job. Okay, where should I move it? Nate, it's up here. Good job. Thank you. Okay. All right, back in business. For our line of reflection, You got to think of y equals mx plus b. What is the b for this line? 0. Okay, what is the slope? -1. Good. So, we're going to go through the origin. And our slope is going to be down 1, right 1, down 1, right 1, down 1, right 1. Okay, make sure you use your straight edge, because if you deviate from that pattern, it's going to mess up your reflection. Okay. What do you notice about R? It's on the line of reflection. So where will all R prime be? Same place, on the line of reflection. Okay, what about S? Can you tell where S is going to land? Can you see it's going to be right here? Yeah, 0, -5. Some of you will be able to see it. Okay, what if we didn't have a graph? What would we do? Well, let's write down the coordinate rule. So it says X and Y are the input, and we're going to map those to, remember, we're going to switch their spots and change their signs. So it'll be the opposite of Y, the opposite of X. So now we just apply this coordinate rule to those points. So R prime, I like to switch the spots and then change the signs, otherwise I can't remember what I've done. But that's just me. You know what I mean? Like, I can't do too much at once. So I'm going to write 2, -2, and then I'm going to change their signs to the opposites. So this is going to be a negative and this will be positive. That's how I have to do it, otherwise I get really confused. Facts. Okay, what about S? Okay, I'm going to switch their spots, 0, 5, and change their signs. What's the opposite of 0? 0. And then I make the 5 negative. And that's where we landed. Okay, translations transform are the type of transformation where all of the points in a figure are shifted the same distance in the same direction along a vector. Okay, we did that just without coordinates. A translation is an isometry, like rotations and reflections, so the image of a translated figure is congruent to the pre-image. So you can see here, if I'm shifting A to A prime, it's moving that far in that direction. That is my translation vector. Okay, it's that far that way. Has magnitude and direction. Okay. These are going to be so nice. Okay, if this is our little difference A, you see that I'm just taking whatever my X was and I'm adding A to it to shift it to the right? Everybody see it? Okay. And then if I wanted to shift up instead, I could take whatever my y is and add b to it, and I'd land up there. What if I wanted to shift right and up at the same time? Well, then I just add an a and a b. Add one to my x, one to my y. That's really it. You guys are going to love this. So, this one is x plus a. This one is y plus b. This one is x plus a, y plus b. Okay, I want to point out that this is the coordinate rule. Okay, and this is the vector. So sometimes you might have to go back and forth between the coordinate rule and the vector. Does everybody see how we would do that? We just use the a and the b for the vector only. Okay. So a vector has these fun little parentheses that kind of look like arrows. A, B, like that. All right, let's try. Okay, we're supposed to translate our triangle using this rule that says right 3 and down 1. So what would that be? How would I make this coordinate rule into a vector? What would the A be? Yeah, 3. Okay, what would the B be? I'm not adding 1, negative 1, I'm subtracting 1. Good. Everybody see where those came from? Okay. So, if we didn't have a picture, could we use this rule or that vector and find the image vertices? What would that look like? Well, what would d prime be if I added 3 to the x? What's negative 3 plus 3? 0. Okay, what about negative 1 minus another 1? Good. All right, what about e prime? I've got 5, but I add 3 more. 8. And then I'm at negative 3, and I want to shift down 1 more. Negative 4. Okay, for f prime, 2 plus 3 is 5. Negative 8 minus 1, negative 9. So, did I need the graph? No, I can just use the coordinate rule. Okay? Alternatively, I don't need to use the coordinate rule and get the vertices. I can just do it on the graph, where I can do both. So, for each of my pre-image points, I'm going to shift them right 3 and down 1. So here's my d prime. Okay, right 3 down 1 for my e prime. For f prime, right 3 down 1. They're all going the same distance in the same direction. And then you can connect your vertices with your straight edge, and you're done. Oops, I went to D and not to D prime. I was like, that doesn't look right. Okay. Right, this one was really crooked. Okay, that's better. Okay, a couple of notes. What do you notice about E prime and F prime compared to E and F, like the segment. What? Parallel. Okay? It's got to be parallel. Let's look at the slopes. So to go from F to E, it's up 1, 2, 3, 4, 5, and right 3. So this slope is 5/3. Okay, let's find this slope. Up 1, 2, 3, 4, 5, right 3. So this slope is also 5/3. So if you've done this correctly, all of your sides should be parallel to your pre-image sides. What else do you see as parallel? This one might be harder to see. I can draw them in red. Do you see that all my vectors are parallel? They're all going down 1, right 3. Okay? So if something is crooked, mayday, go back and check your work. Okay, let's flip. Guys, do we need to do number 5? Okay, we're going to do number 6 really quick. All right, so we want the vector, and then we also want the coordinate rule. So be careful because it's kind of tempting to go, but is that the way I'm supposed to go? How do I know which one is the pre-image? Yeah, it's got, the letters have no primes. So this is the pre, and then this is the image. So make sure that you are making the correct one, the input and output. So let's figure out what transformation happened to go. It doesn't matter which one because they should all be the same. Which one do you want to use? A? So A is going left 1, 2, 3 and up 1, 2, 3, 4, 5, 6, 7. So my vector is going to be left 3, oops, that's parentheses, vector left 3, up 7. Now I need to write that as a coordinate rule. So that'll be my x, y, maps to x something, y something. What do you think? X what? -3. And then the y? Good. Questions? Okay, rock and roll. Okay, so I want you to do the same thing, the coordinate rule and the vector, but this time you don't have a picture. All you have are the coordinates. So you have to look at the coordinates very carefully and see if you can figure it out. Go. Okay, check yours with mine. How did I do? Good? Okay, that's going to be it for today.